Hi, and welcome to the second video for section 7.2.1. If you haven't already, please watch the first video in which we do problem 7-113. That will be linked in the description below. If you haven't already watched that video, please watch that video first. Now let's go ahead and talk about 7-114. Please read this problem with your team and also read your task. Go ahead and pause the video to do this now. Now that you've read problem 7-114, let's talk about what it's asking us to do. So it wants us to investigate the graphs of y equals sine of x and y equals cosine of x completely. So we want to make the graphs, find the domain and range, and label any important points or asymptotes. Then it wants us to make a sketch and write an equation to demonstrate each transformation of the sine or cosine function that you can find. Finally, it wants us to find a general equation for a sine and cosine function. Then to be prepared to share what we found with the class. So, as you can see, I already set up two sections. So y equals sine of x to find the domain, range, and general equation, and y equals cosine of x to find the domain, range, and general equation. I'm going to be using Desmos, but I would like for you on your papers to also add a sketch of the graph for both graphs. So you can use Desmos as well, but please include a sketch of these graphs as well on your notes. So go ahead and pause the video to set up your paper to be ready to do this problem. Go ahead and pause the video now. So just a reminder about what domain and range mean. Domain is referring to all of the x values that are possible for a graph, and range is all of the y values that are possible for the graph. So when you go through and look at your graphs, be sure to remember that domain has to do with the x values and range has to do with the y values. So like I said, we're going to be using Desmos to work through this problem. So let's go ahead and graph y equals sine of x. So functions, or we could just type it, sine of x. So y equals sine of x. Now let's go ahead and think about what's the domain, what's the range. On your sketch, label any important points. You know that if you click on the graph, you can click on points. So go ahead and label any important points on your sketch, and also see if you can find a general equation. But first, find that domain, range, and label any important points on your graph. Now that you've gone on Desmos to look at your graph and find your domain and range, let's go ahead and talk about what they are. So domain is the x value, so we can see on the graph that for pretty much every x value that we can see, there's a point on the y, there is a y value, so there's a point at every x value. So we're going to say it's from negative infinity to positive infinity, or all real numbers. Our range, on the other hand, when we look at the y values, they pretty much stay in the exact same place. So let's see what the highest number is. That'd be 1. The lowest y value is -1. So it goes from -1 to +1, or -1 is less than or equal to y is less than or equal to 1. So go ahead and check your answers for domain and range for sine of x now. Pause the video to do this now. Now that we've looked at sine of x, let's go ahead and look at the graph for cosine of x. I'm actually going to leave the graph for sine of x up and just hit the little dot next to it so it's not highlighted, just to keep it for later. So we're going to have y equals cosine of x. So now I have this graph for y equals cosine of x. Go ahead and pause the video now to look through and find the domain and range of cosine of x. Now that you've gone and looked at the graph on Desmos for y equals cosine of x, let's go ahead and find the domain and range for that graph. So if we look at the x values, the domain, let's go ahead and look at this graph. Seems like it goes on forever, both ways. So just like the last graph, we can say that the domain is negative infinity to positive infinity. We can plug in any angle and find a cosine, or all real numbers. For the range, so the y values, let's go ahead and look at the graph. So just like the sine graph, we can see that it kind of stays in the same area the whole time. So let's go ahead and find what that maximum y value is right up here. It's 1, and what that minimum, -1. So let's go through, and we can say that it's -1 to +1, or once again, -1 is less than or equal to y is less than or equal to +1. Go ahead and pause the video now to check these answers. So on the graph, we're also looking for important points. So any x-intercepts, y-intercepts, anything that looks important like a minimum or a maximum, go ahead and mark now on your sine graph and your cosine graph. Go ahead and mark these now, and then we'll go over what they are. So for your sine graph, any important points would be the y-intercept, so 0, 0, and any x-intercepts, such as pi 0, 2 pi 0, and so on if we move in both directions, so also -pi 0. Other important points would be a maximum, such as pi over 2, 1, or a minimum, such as 3 pi over 2, 1. -1. There are no asymptotes for this graph, so we don't have to worry about that. Go ahead and make sure your graph has important points labeled. Now looking at the graph for cosine, any important points that we can see would be like the y-intercept, which is 0, 1, x-intercepts, such as pi over 2, 0, and 3 pi over 2, 0, as well as going the other direction to find -pi over 2, 0, and -3 pi over 2, 0. We can also look at minimums and maximums, such as 0, 1, 2 pi, 1, and pi, -1. Again, there are no asymptotes for this graph, so these are the important points that we can label on our sketches. Go ahead and make sure you have these points labeled now. So now we're at the part of the problem where we want to find a general equation for our graphs. So for y equals sine of x, just go ahead and try to find a general equation using what you know about general equations. So equations you can use and alter to find shifts horizontally, vertically, or stretches and compressions of the graph. Go ahead and do this now. Now that you've done your best to find a general equation, I'm going to go ahead and write down what the general equation of sine of x is. The general equation is y equals a times sine of bx plus c. I wrote this kind of wonky, so let me fix it. There. So y equals a times sine of bx plus c. So now I want you to go ahead and write down what A, B, and C mean. And how I want you to go about doing this is if you go on to Desmos, let's go on to Desmos, and look at this sine graph. So let me type it in. Y equals a times sine of bx plus c. It gives me this option to add sliders. So I'm going to say all. And if I want to find out what a does, I can go ahead and hit this play button, or I can move my dot around manually to find what a does for different values of a. I can do the same for b and c. So go ahead and work through these now to figure out what a, b, and c mean. Now that you've gone through y equals sine of x and finding the general equation and what a, b, and c mean, I want you to make sure you have that all written down, because I'm not going to tell you what it means. I want to see your thoughts when you submit your notes. So please make sure that you have this part filled out when you submit your notes. I really want to see what your thoughts are about what a, b, and c are. So go ahead and pause the video now to make sure you have this all written down. Now that you've written down everything for sine, let's go ahead and talk about the general equation for cosine. Looking at what we have for sine, what do you think the general equation for cosine is? Go ahead and pause the video now to find the general equation for cosine. Now that you've worked on your own to find the general equation for cosine, let's go over what it is. So it's y equals a times cosine of bx plus c. Once again, it looks really similar to the sine general equation. So once again, we're going to find out what a, b, and c mean. So how we do this, once again, let's go through, is on Desmos, we go ahead and type in our general equation, a times cosine of bx plus c, and it'll let us have these sliders again. It looks like it's having us keep the same sliders as for sine. So if we want to adjust a, we can use that slider. If we want to adjust b, we can use that slider, and c, so on and so forth. So you go ahead and use these sliders to find out what a, b, and c do to the graph of cosine. Once again, I will not be giving you the answers for what a, b, and c mean in the general equation, so be sure to have these written down before you submit your notes to me on Google Classroom. Go ahead and take a photo of your notes before you submit them on Google Classroom, and let's go through what we did on this problem. So we went through and we found the domain and range of sine and cosine. They were the exact same. You can plug in any angle to both, so they both go from negative infinity to infinity, or all real numbers for the domain. And they have a range from -1 to +1. And we labeled the important points, so x-intercepts, y-intercepts, minimums, and maximums on the graph. Then we found the general equation and investigated what a, b, and c mean using sliders on Desmos. If you have any questions about what we did today, be sure to log in to Google Classroom or Google Meets. My class, Miss Red's class, meets every Monday through Friday from 11 a.m. to 12 p.m. But if your class meets at a different time, be sure to check in with your teacher to find when you will be meeting with your teacher on Google Meets or Zoom. Have a great day, and be sure to stay safe and stay healthy. Thank you.